Okay, so in this section we'll be talking about the inverse Laplace transform, and it's basically just to be defined to be the inverse of the Laplace transform. So if you go Laplace inverse of Laplace of, say, some function f, it should become f. So you can think of these Laplace and Laplace inverse as cancelling. Okay, so let's recall some things. Okay, so from Theorem 13 we proved that the Laplace transform of e to the at was 1 over s minus a. So it means then if you take Laplace inverse on both sides, it's become e here. It'll be Laplace inverse of this. So it would imply then the Laplace inverse of 1 over s minus a is equal to e to the at. From Theorem 14 we showed that the Laplace transform of t to the n was n factorial over s n plus 1. So taking Laplace inverse on both sides, we'd have Laplace inverse then of n factorial over s to the n plus 1 equals t to the n. And by Theorem 15, we have the Laplace transform of sine kt equals k over s squared plus k squared. So taking Laplace inverse on both sides, we'll have then sine equals Laplace inverse of this guy here, so k over s squared plus k squared. And lastly, in Theorem 15 we also show the Laplace of cosine of kt is s over s squared plus k squared. So taking Laplace inverse on both sides, we'll have then Laplace inverse of s over s squared plus k squared equals cosine of kt. Okay. So now let's take a look at an example using this Laplace transform. So let me erase these things and we'll do our example. Okay, so here's our question from Practice Quiz 8, problem 1. Our example says find the inverse Laplace transform. We have Laplace inverse of 8s squared plus 5s plus 3 over 2s plus 1 times s squared plus 1. So we're looking for a function f whose Laplace transform becomes this. Let me write that here. So calling this guy f. So we need to find some f of t such that the Laplace transform of ft equals 8s squared plus 5s plus 3 over this. Okay, in order to do this, we're going to first look at the partial fraction decomposition of this guy here. So let's do that. Okay, so we're going to first find the partial fraction decomposition of this guy here. So we'll have our 8s squared plus 5s plus 3 guy over here equal then a over the first factor here, which is 2s plus 1, plus here the s squared plus 1 is a quadratic factor, and I guess if you factored it, you would have imaginary numbers as the factored parts, so I'm not going to do that. So if you keep it as a quadratic piece like we have here, an s squared plus 1, on top then you'd have, it should be a c here. You'd have a bs plus c guy up here. As basically, since it's an s squared, you have to go s and a constant term. So you're going to have a bs plus c term here. So our job then is to find the a, b, and c that make this a true statement. Okay, so let's multiply, let's call this guy here d. Okay, so I call it d here. So we're going to multiply both sides by d. So let's do that. Okay, so multiply both sides by d. Multiplying this side by d, they'll cross off with that guy down here. So you'll just be left with 8s squared plus 5s plus 3 on the left side. Then it'll be a over 2s plus 1 times my d. So here's my d, 2s plus 1, s squared plus 1 over 1. Then my bs plus c over s squared plus 1 times my d. So 2s plus 1 times s squared plus 1. And notice here the 2s plus 1 will cross off here. And the s squared plus 1 will cross off here. Okay, so I'm out of space, so let me erase a few things and we'll continue. Okay, so we get this then. So we have 8s squared plus 5s plus 3 equal a times s squared plus 1 plus bs plus c times 2s plus 1. We could multiply this out over here and then equate coefficients. That's one way to do it. Or maybe a more efficient way might be, notice here we can make the 2s plus 1 equal to 0. Then the b and the c would be gone and I'd be just left on a. So let's set the 2s plus 1 equal to 0 first. So to solve for a, we're going to set the 2s plus 1 equal to 0. Solving for s then, that would mean that s is equal to negative 1/2. Now we're going to stick a negative 1/2 in place of s here, in place of all the s's up here. So doing that we get then. Okay, so we're putting negative 1/2 in place of s everywhere, so it'll be 8 times negative 1/2 squared plus 5 times negative 1/2 plus 3, then equals a times negative 1/2 squared plus 1 plus b times s with negative 1/2 plus c 2 times negative 1/2 plus 1. But by design, this is 0, this part here. So simplifying what we have, we get then. So simplifying, this would be 8 over 4 minus 5/2 plus 3 equals 1/4 plus a. You can combine the 3 and that's 2, so it'll be 5 minus 5/2 a 1/4 plus 1. Let's multiply both sides by 4 to clear the fractions, so doing that. Okay, so multiplying both sides by 4, 4 times 5 would be 20, 4 times 5/2 would be 10, 4 times a fourth would be 1, 4 times 1 is 4, so you'll have 5a equals 10, so a is 2. Okay, so we can replace the a up here with the 2 now, so let's do that. Okay, so replace it up there. And next, we could say, notice here if I let s be 0, the b would disappear. So it looks like I can find c by letting s equal 0. All right, let's do that. So we can find c by letting s equal 0. So put 0 in place of s everywhere up here. So it'd be 8 0 squared plus 5 times 0 plus 3 equals 2 times 0 squared plus 1. b times 0 plus c 2 times 0 plus 1. So simplifying this we get then. So simplifying we get then 3 equals 2 plus c, so c is 1. So we found our c value now, so we know this guy appears. Let me replace that now. So replacing that now with 1 we get this then. So we're just missing now the b in here. Okay, so I'm out of space. Let me erase a few things and we'll keep going. Okay, so we're just left with b to find. We found a is 2, c is 1 over here. So different ways you could find b. I think the easiest way is just to equate coefficients. Let's multiply stuff out over here and we'll equate the coefficients. So doing that we get then. Okay, so multiplying, it'd be 2 times s squared, 2s squared plus 2 times 1, 2. bs times 2s, 2bs squared, bs times 1, bs, 1 times 2s, 2s, 1 times 1, 1. Let's combine the s squared terms and the s terms. So doing that we get. Okay, so combining the s squared coefficients, it'll be 2 plus 2b s squared. And combining the s coefficients, it'll be bs here. And 2s here, so it'll be b plus 2s plus 3, 2 plus 1. So we can equate the coefficients then. So equating coefficients we get, Okay, so equating coefficients, we have our 2 plus 2b is the coefficient in front of s squared here, must equal the coefficient in front of s squared here, so it needs to equal 8. And the b plus 2 coefficient in front of the s must equal 5, which is the coefficient in front of the s on this side. So we have these two equations, and if you subtract 2 here, it looks like b is 3, and that should work here also. So it looks like b is 3. Okay, so our partial fraction decomposition, so it's going to be a over 2s plus 1, but the a we found was 2, so it's going to be 2 over 2s plus 1 plus bs. Our b we found is 3, so it'll be 3s plus c, or c is 1, over s squared plus 1. And I'm going to break this up even further now. I'm going to break the top into two fractions here. Let me do it here. Okay, so broken up this fraction as 3s over s squared plus 1 over s squared plus 1. Now let's take Laplace inverse on both sides here. Okay, so taking Laplace inverse on both sides, and the Laplace inverse is linear, so it means Laplace inverse of this guy will be Laplace inverse of this one, plus Laplace inverse of this one, plus Laplace inverse of this one. And it's pretty much linear is because the Laplace transform we proved was linear. Therefore, the inverse Laplace would have the same property. Okay, let's keep going here. So I'm out of space. Let me erase a few things and we'll keep going. Okay, so we're going to be using these recalls now. So recall, we said the Laplace inverse of 1 over s minus a is e to the at. The Laplace inverse of k over s squared plus k squared is sine kt. The Laplace inverse of s over s squared plus k squared is cosine kt. So this guy looks like this one. We need to make a slight adjustment, but it has to be this one, it looks like. Because there's an s there, no s up here, there's no s squared. This is an s squared, and it has an s on top, so it would have to agree with the one over here. We have to make it look like that. And this is an s squared in the bottom, and no s on top, so it's going to look like this. So let me note that here. So first note, the Laplace inverse of 2 over the 2s plus 1. Well, we're trying to match it up with this one. It just has an s down here. So we need to get a 1 in front of the s. We have a 2 in front of the s right now. So if I multiply top and bottom by 1/2, that would change that to a 1. So let's multiply top and bottom by 1/2. So it'll be 1/2 times 2, 1. 1/2 times 2s, just be s. 1/2 times 1, a half here. But now it has to be s minus a, so we can write this as follows. Okay, so we can write the s plus 1/2 as s minus 1/2. Therefore, the a would be negative 1/2. So it'll be e to the at. So it'll be e to the negative 1/2 times t. What you can write as e to the minus t over 2. Okay, so we figured this guy out. Let's work on, say, this one next. So actually I'm going to erase this now and we'll work on this one. Okay, so the Laplace inverse of 3s over s squared plus 1, we'll be using this guy on that one. I actually got these backwards here. This one should have went with the one over here. And this one with this guy over here. Okay, so we'll be using this guy over here. It just has an s on top. So we have a 3 in here. We need to get rid of the 3. I can just pull the 3 outside the Laplace inverse like I've done here. So just pull the 3 out. And now it's that form pretty much, because you can write 1 as 1 squared. So it looks like here k is 1, so let's note that. Okay, so our k is 1 here. So we just plug into that, it's going to be cosine of kt. K is 1, so it's cosine of t, but we have a 3 in front, so it's going to be 3 cosine of t. Okay, so we've done this one. Let's work on this one next. Let's write down here. Okay, so working on this one, Laplace inverse of 1 over s squared plus 1. We can think of 1 as 1 squared. We're trying to match it up with this guy. So therefore k is going to be 1. So it looks like it's in this form already. So k is 1, so it's just going to be sine of t. Okay, so let's write our final answer now. So let me erase a few things and we'll write our final answer. Okay, so our final answer then will be Laplace inverse, so our f of t function will be e to the minus t over 2 plus 3 cosine of t plus sine t. Okay, so we're done. So let's leave it there.